Before we carry on with solving simultaneous equations, I want to preempt what we're going to look at next, which is solving equations that are of this form. So both of them are of the form ax plus by equals c. Okay? Now, with the method that we've been using up to now, we've been using a substitution method, which essentially just allows you to substitute one equation into the other, or put one equal to the other. Okay, it's the same thing. Okay, whereas when you've got equations like this, you can't do that because neither of the two equations are y equals or x equals that would allow you to do that substitution. Okay, so what are we going to do? How can we solve these? Well, there are two methods really open to you. One of them is to rearrange one of the equations to make y equals or x equals, and then substitute it into the other. That can get a little bit messy, okay? So instead, there is another method that we can use in this instance, and that's called the elimination method. So really what I want you to kind of like understand here is that when you have an equation like that first one, okay, in fact, let's number them. This is what we're going to do. We are going to end up numbering the two equations, okay? So we'll call the first one equation 1, we'll call the second equation number 2, okay? Now, if I multiplied the first equation through by something, so let's say 3, so if I multiply equation 1 by 3, okay, and we get 6x plus 9y is equal to minus 9, okay? Let's call this equation number 3. Equation 1 and equation 3 are both the same, okay? I haven't changed the equation. I've multiplied it through by a constant term. I won't have changed anything really about it, okay? So let's do something similar to equation 2. Let's multiply equation 2 through by 2. Now you may be wondering, why am I multiplying the first one through by 3 and why am I multiplying the second one through by 2? Okay? Why have I chosen those numbers to multiply it by? Because theoretically I can multiply them through by anything, and I'm not going to change the size of the equation. So let's see what we get when we multiply this through by 2. We're going to get 6x plus 8y is equal to minus 4. And we'll call this equation number 4. Okay? So now I've got 6x and 6x in both of the equations. Now, what you can do with these equations is you are allowed to, and are able to, add and subtract multiples of these equations to one another without creating any problems, without changing the equation. Okay, so if I was to do equation 3 and subtract equation 4, that is a perfectly valid move, okay? Now, why would I do that? Well, now that I've got 6x and 6x, when I do 6x take away 6x, they're gone, okay? And then I would have 9y take away 8y, which I know is just y, and minus 9 take away minus 4 is minus 9 plus 4, which is minus 5. So through doing this, I've worked out that y must be minus 5. Okay? And then I need to work out what the x value is. Well, what I need to do is then substitute this into one of the two original equations. And it doesn't matter which one. Just choose the one that looks easiest, which I think is the first one. So if I sub into 1, okay, then I'm going to get 2x plus 3 lots of minus 5 is equal to minus 3. So 2x take away 15 is minus 3. Add the 15 to both sides and then divide through by 2. So x is equal to 6. So the two lines intersect at 6 minus 5. Okay, so what you're seeing is this method of what's referred to as the elimination method, and it's called that elimination method because you are eliminating one of the variables. The target is to multiply your two equations by values that will allow you to eliminate one of them. Now, I chose to eliminate the x's. You could equally have tried to eliminate the y's. You could multiply this one through by 4 to get 12y. You multiply that one through by 3 to get 12y, and then subtract 1 from the other. And that will work as well. Okay? Let's try that out. Let's do it. Now I'm going to leave that there, okay, just to kind of like be clear that that was my answer. And you'll have noticed that what I'm doing is I'm also annotating what I'm doing. And I'm making it clear what my process is. This is very important, okay? Because what you're trying to do is you're trying to make it as clear as possible for anyone who'd be marking your work so they can follow it, okay? Without that, marking this type of question can be very tough, okay? And if you make it hard for your marker to follow, you know, then there might be problems and you might lose marks. So, we're going to multiply equation 1 through by 4. So we're going to get 8x plus 12y is equal to minus 12. Multiply equation 2 through by 3. So we're going to get 9x plus 12y is equal to minus 6. And we'll call this equation number 3 and this one number 4. Now you could do 3 take away 4, or you could do 4 take away 3. 4 take away 3 seems better because then I'm going to get a positive number of x's, right? 9x take away 8x is x. 12y take away 12y is 0. Minus 6 take away minus 12 is minus 6 plus 12, which is 6. And then if I substitute that into one of the two equations, let's say the first one, so sub into 1, 2 lots of 6 plus 3y is minus 3, so 12 plus 3y is minus 3. Take 12 from both sides, and then divide through by 3. And we get x is 6, y is minus 5, as we had before. Okay, so it doesn't matter which one you're trying to eliminate, which variable you're trying to eliminate, but just make your process clear, okay? Sometimes it's going to be easier to eliminate the x's rather than the y's, or sometimes it can be easier to eliminate the y's rather than the x's, but it really comes down to the question that you're involved with, okay? So you can multiply your equations through or divide them through, okay? And that won't be an issue. You can add the two equations together, or if this had been take away 12y, you could have added the equation. So you could subtract them, you can add them, whichever makes most sense in order to eliminate the variable.